Gilli Pong.
Welcome to Gilli Pong analysis. I'm continuing with How to Lie with Statistics by Darrell Huff. We are on Chapter 3, and on we go. Chapter 3, The Little Figures That Are Not There. Users report 23% fewer cavities with the Dokes toothpaste, the big type says. You could do with 23% fewer aches, so you read on. These results, you find, come from a reassuringly independent laboratory, and the account is certified by a certified public accountant. What more do you want? Yet, if you are not outstandingly gullible or optimistic, you will recall from experience that one toothpaste is seldom much better than any other. Then how can the Dokes people report such results? Can they get away with telling lies, and in such big type at that? No, they don't have to. There are easier ways, and more effective ones. The principal joker in this one is the inadequate sample, statistically inadequate, that is. For Dokes' purpose, it is just right. The test group of users, you discover by reading the small type, consisted of just a dozen persons. You have to hand it to Dokes at that for giving you a sporting chance. Some advertisers would omit this information and leave even the statistically sophisticated only a guess. Statistically sophisticated only a guess as to what species of chicanery was afoot. His sample of a dozen isn't so bad either, or as these things go. Something called Dr. Cornish's tooth powder came onto the market a few years ago with a claim to have shown considerable success in correction of dental caries. The idea was that the powder contained urea, which laboratory work was supposed to have demonstrated to be valuable for the purpose. The pointlessness of this was that the experimental work had been purely preliminary and had been done on precisely 6 cases. But let's get back to how easy it is for Dokes to get a headline without a falsehood in it, and everything certified at that. Let any small group of persons keep count of cavities for 6 months, then switch to Dokes. One of 3 things is bound to happen: distinctly more cavities, distinctly fewer, or about the same number. If the first or last of these possibilities occurs, Dokes and Company files the figures well out of sight somewhere and tries again. Sooner or later, by the operation of chance, a test group is going to show a big improvement worthy of a headline and perhaps a whole advertising campaign. This will happen whether they adopt Dokes or baking soda or just keep on using their same old dentifrice. Don't know that word. Dentifrice. The importance of using a small group is this. With a large group, every difference produced by chance is likely to be a small one and unworthy of big type. A 2% improvement claim is not going to sell much toothpaste. How results that are not indicative of anything can be produced by pure chance, given a small enough number of cases, is something you can test for yourself at small cost. Just start tossing a penny. How often will it come up heads? Half the time, of course. Everyone knows that. Well, let's check that and see. I've just tried 10 tosses and got heads 8 times, which proves that pennies, by actual test, one test, science proves that tossed pennies come up 80% of the time. Come up heads 80% of the time. Come up heads 80% of the time. Yeah. Well, by toothpaste statistics, they do. Now try it yourself. You may get a 50-50 result, but probably you won't. Your result, like mine, stand a good chance of being quite a ways away from 50-50. But if your patience holds out for 1,000 tosses, you are almost, though not quite, certain to come out with a result very close to half heads, a result, that is, which represents the real probability. Only when there is a substantial number of trials involved is the law of averages a useful description or prediction. How many is enough? That's a tricky one too. It depends, among other things, on how large and how varied a population you're studying by sampling. And sometimes the number in the sample is not what it appears to be. A remarkable instance of this came out in connection with a test of a polio vaccine a few years ago. It appeared to be an impressively large-scale experiment as medical ones go. 450 children were vaccinated in a community, and 680 were left as controls. Just gonna try to do like this. Stop it. Give me a chance to just go down. Thank you. 680 were left unvaccinated as controls. Shortly thereafter, the community was visited by an epidemic. Not one of the vaccinated children contracted a recognizable case of polio. Neither did any of the controls. What the experimenters had overlooked or not understood in setting up their project was the low incidence of paralytic polio. At the usual rate, only 2 cases would have been expected in a group this size, and so the test was doomed from the start to have no meaning. Something like 15 or 25 times this many children would have been needed to obtain an answer signifying anything. Many a great if fleeting medical discovery has been launched similarly. Make haste, as one physician put it, to use a new remedy before it is too late. The guilt does not always lie with the medical profession alone. Public pressure and hasty journalism often launch a treatment that is unproved, particularly when the demand is great and the statistical background hazy. So, it was with the cold vaccines that were popular some years back and the antihistamines more recently. A good deal of the popularity of these unsuccessful cures sprang from the unreliable nature of the ailment and from a defect of logic. Given time, a cold will cure itself. How can you avoid being fooled by unconclusive results? Most every man be his own statistician. Must every man be his own statistician and study the raw data for himself? It is not that bad. There is a test of significance that is easy to understand. It is simply a way of reporting how likely it is that a test figure represents a real result rather than something produced by chance. This is the little figure that is not there, on the assumption that you, the lay reader, wouldn't understand it. Or that where there is an axe to grind, you would. If the source of your information gives you also the degree of significance, you'll have a better idea of where you stand. This degree of significance is most simply expressed as a probability, as when the Bureau of Census tells you that there are 19 chances out of 20 that their figures have a specified degree of precision. For most purposes, nothing poorer than this 5% level of significance is good enough. For some, the demanded level is 1%, which means that there are 99 chances out of 100 that an apparent difference or whatnot is real. Anything this likely is sometimes described as practically certain. There's another kind of a little figure that is not there, one whose absence can be just as damaging. It is the one that tells the range of things or their deviations from the average that is given. Often, an average, whether mean or median, specified or unspecified, is such an oversimplification that it is worse than useless. Knowing nothing about a subject is frequently healthier than knowing what is not so, and a little learning may be a dangerous thing. Although too much of the recent American housing, for instance, has been planned to fit the statistically average family of 3.6 persons. Translated into reality, this means 3 or 4 persons, which in turn means 2 bedrooms. And this size family average, though it is, actually makes up a minority of all families. We build average houses for average families, say the builders, and neglect the majority that are larger or smaller. Some areas, in consequence of this, have been overbuilt with 2-bedroom houses, underbuilt in respect to smaller and larger units. So here is a statistic whose misleading incompleteness has had expensive consequences. Of it, the American Public Health Association says, when we look beyond the why can't I say this word? Arithmetical average to the actual range. Okay, I'll just start with from the beginning. When we look beyond the arithmetical average to the actual range, which is misrepresented, we find that the 3-person and 4-person families make up only 45% of the total. 35% are 1 person or 2 persons. 20% have more than 4 persons. Common sense has somehow failed in the face of the convincingly precise and authoritative 3.6. It has somehow outweighed what everybody knows from observation, that many families are small and quite a few are large. In somewhat the same fashion, these little figures that are missing from what are called Gesell's norms have produced pain in papas and mamas. Let a parent read, as many have done in such places as Sunday rotogravure sections, that a child learns to sit erect at the age of so many months as he thinks at once of his own child. Let his child fail to sit by the specified age, and the parent must conclude that his offspring is retarded or subnormal, or something equally invidious. Since half the children are bound to fail to sit by the time mentioned, a good many parents are made unhappy. Of course, speaking mathematically, this unhappiness is balanced by the joy of the other 50% of parents in discovering that their children are advanced. But harm can come of the efforts of the unhappy parents to force their children to conform to the norms and thus be backward no longer. All this does not reflect on Dr. Arnold Gesell or his methods. The fault is in the filtering down process from the researcher through the sensational or ill-informed writer to the reader, who fails to miss the figures that have disappeared in the process. A good deal of the misunderstanding can be avoided if to the norm or average is added an indication of the range. Parents, seeing that their youngsters fall within the normal range, will quit worrying about small and meaningless differences. Hardly anybody is exactly normal in any way, just as 100 tossed pennies will rarely come up exactly 50 heads and 50 tails. Confusing normal with desirable make it all the worse. Dr. Gesell simply stated some observed facts. It was the parents who, in reading the books and articles, concluded that a child who walks late by a day or a month must be inferior. A good deal of the stupid criticism of Dr. Alfred Kinsey's well-known, if hardly well-read, report came from taking normal to be equivalent to good, right, desirable. Dr. Kinsey was accused of corrupting youth by giving them ideas and particularly by calling all sorts of popular but unapproved sexual practices normal. But he simply said that he had found these activities to be usual, which is what normal means. He did not stamp them with any seal of approval. Kinsey is the one who started this gender ideology, by the way. Whether they are naughty or not did not come within what Dr. Kinsey considered to be his province. He was studying sexuality in kids. So he ran up against something that has plagued many other observers. It is dangerous to mention any subject having high emotional content without hastily saying where you are for or against it. The deceptive thing about the little figure that is not there is that its absence so often goes unnoticed. That, of course, is the secret of its success. Critics of journalism, as practiced today, have deplored the paucity of good old-fashioned legwork and spoken harshly of Washington's armchair correspondents, who live by uncritically rewriting government handouts. For a sample of unenterprising journalism, take this item from a list of new industrial developments in the news magazine Fortnight: a new cold temper bath which triples the hardness of steel from Westinghouse. Now, that sounds like quite a development, until you try to put your finger on what it means, and then it becomes as elusive as a ball of quicksilver. Does the new bath make just any kind of steel 3 times as hard as it was before treatment? Or does it produce a steel 3 times as hard as any previous steel? Or what does it do? It appears that the reporter has passed along some words without inquiring what they mean, and you are expected to read them just as uncritically for the happy illusion they give you of having learned something. It is all too reminiscent of an old definition of the lecture method of classroom instruction, a process by which the contents of the textbook of the instructor are transferred to the notebook of the student without passing through the heads of either party. A few minutes ago, while looking up something about Dr. Kinsey in Time, I came upon another of those statements that collapse under a second look. It appeared in an advertisement by a group of electric companies in 1948 Today, electric power is available to more than 3/4 of U.S. farms. That sounds pretty good. Those power companies are really on the job. Of course, if you wanted to be ornery, you could paraphrase it into almost 1/4 of U.S. farms do not have electric power available today. The real gimmick, however, is in the word available, and by using it, the companies have been able to say just about anything they please. Obviously, this does not mean that all those farmers actually have power, or the advertisement surely would have said so. They merely have it available, and that, for all I know, could mean that the power lines go past their farms and merely within 100 miles of them. Worldwide availability of how to lie with statistics. Areas with 25 miles of railroad, motorable road, port, or navigable waterway, dog sled routes not shown. Yeah. Let me quote a title from an article published in Collier's in 1952. You can tell now how tall your child will grow. With the article is conspicuously displayed a pair of charts, one for boys and one for girls, showing what percentage of his ultimate height a child reaches at each year of age. To determine your child's height at maturity, says a caption, check present measurement against chart. The funny thing about this is that the article itself, if you read on, tells you what the fatal weakness in the chart. I'm still on this here. Tells you of the fatal weakness in the chart is. Not all children grow in the same way. Some start slowly and then speed up. Others shoot up quickly for a while and level off slowly. For still others, growth is a relatively steady process. The chart, as you might guess, is based on averages taken from a large number of measurements. For the total, or average, heights of 100 youngsters taken at random, it is no doubt accurate enough. But a parent is interested in only one height at a time, a purpose for which such a chart is virtually worthless. If you wish to know how tall your child is going to be, you can probably make a better guess by taking a look at his parents and grandparents. That method isn't scientific or precise like the chart, but it is at least as accurate. I am amused to note that, taking my height as recorded when I enrolled in high school military training at 14, and it ended up in the rear rank of the smallest squad, I should eventually have grown to a bare 5'8". I am 5'11". The 3-inch error in human height come down to a poor grade of guess. Before me are wrappers from 2 boxes of grape nuts flakes. They are slightly different editions. As indicated by their testimonials, one cites 2 Gun Pete, and the other says, if you want to be like Hoppy, you've got to eat like Hoppy. Both offer charts to show. Scientists proved it's true that these flakes start giving you energy in 2 minutes. In one case, the charts hidden in these forests of exclamation points has numbers up the side. On the other case, the numbers have been omitted. This is just as well, since there's no hint of what the numbers mean. Both show steeply climbing red line. Of the energy release. Yeah, both show steeply climbing red line, energy release, but one has it starting 1 minute after eating grape nuts flakes, and the other 2 minutes later. One line climbs about twice as fast as the other two, suggesting that even the draftsman didn't think these graphs meant anything. Such foolishness could be found only on material meant for the eye of a juvenile, or his morning-weary parent, of course. No one would insult a big businessman's intelligence with such statistical stripe. I can't say this word, by the way. Statistical stripe. Or would he? Let me tell you about a graph used to advertise an advertising agency. I hope this isn't getting confusing. I hope this isn't getting confusing. In the rather special columns of Fortune magazine, the line on this graph showed the impressive upward trend of the agency's business year by year. There were no numbers. With equal honesty, this chart could have represented a tremendous growth, with business doubling and increasing by millions of dollars a year, or the snail-like progress of a static concern adding only $1 or $2 to its annual billings. It made a striking picture, though. Place little faith in an average or a graph or a trend when those important figures are missing. Otherwise, you are blind as a man choosing a campsite from a report of mean temperature alone. You might take 61 degrees as a comfortable annual mean, giving you a choice in California between such areas as the inland desert and San Nicolas Island off the south coast. But you can freeze or roast if you ignore the range. For San Nicolas, it is 47 to 87 degrees, but for the desert, it is 15 to 104. Oklahoma City can claim a similar average temperature for the last 60 years, 60.2 degrees. But as you can see from the chart below, that cool and comfortable figure conceals a range of 130 degrees. -7 to 113. Yeah. Thank you so much for watching. This was chapter 3 of How to Lie with Statistics. And have the most beautiful present moment, now and always. And remember, it's time to shine. So, let's glow!
Gilli Pong.
Analysis.